Hello students, welcome to my lecture. Today we are going to discuss few questions related to JEE main examination. Clear friend? So let's start the session with question answer round. Now look at my first question is, read the question carefully. Which of the following act as depressant in froth flotation of galena? As we know, froth flotation is used for sulfide ores. Now what will happen? Look at that is, which of the following depressant in the froth flotation of galena which contains ZNS. What will happen? Such compound will act as a depressant, such molecule will act as a depressant which form complex with ZNS. As we know in general while discussing the lecture, ZNS when treatment with NaCN or KCN, they form complex, that is Na2ZnCN whole 4 and the rest product is Na2S. Due to the formation of complex, it acts as a depressant. So for the froth flotation process which act as a depressant, so it is NaCN or KCN. One more thing, sodium ethyl xanthate is not it is not act as a depressant that is depress the formation of froth. So this one is NaCN or KCN. Clear to you friend? So for question number 1, D is the correct option. Explanation is here. Due to the formation of complex, it form complex with ZNS and these are depressant. Clear friend? Now I'm going to rub this part and we'll discuss the next one. Now let's move to the question number 2. Which is beta oxidizing agent for the reduction of ZNO? As we all know, oxidizing and reducing agent for any extraction process is governed by the Lingam diagram. We know what is the Lingam diagram? That is the graph between delta Z and temperature gives you a diagram which is known as Lingam diagram, as I discussed earlier. Now what is the graph between delta G and T? Look at this thing, delta G and T. Clear to you? There is 3 possibilities like this. The graph may be like this. If there is any breaking, that is, it shows that there is a phase change. Clear? Graph may be like this. It shows that the slope is negative. The graph may be like this. It shows that the slope is positive. That is, in this case, delta G becomes less negative, that is becomes positive. In this case, the delta G becomes more and more negative. And the graph may be like this at a particular temperature. There is 3 conditions. Clear? Up, delta G become less negative. Down, delta G become negative. Breaking, that is the phase change. Clear? This is the basic concept related to the Lingam diagram. That is the graph between delta G and T gives you Lingam diagram. Now I am going to rub this part and we'll discuss the graph related to the question. Now here is given ZNO. This is the graph. Look at what I am telling. That is delta Z and T. Clear to you? Now this is the graph of ZNO. Clear to you? ZNO. Now this is the graph for CO and this is the graph for C which gives CO. Clear to you? Here C which gives CO2, here CO plus O2 which gives CO2. Now, by looking at, there is a phase change also, by looking at this graph, what we observe? Sir, which is the better oxidizing agent? Carbon is the better oxidizing agent in this case. Remember what I'm telling? By looking at this graph, we can easily assume, we can easily predict that carbon is the best oxidizing agent in comparison to carbon monoxide. Generally, carbon dioxide is not taken as a oxidizing agent. So for this question, A is the correct option. Clear to you what I'm telling? For this question, A is the correct option. Now, I'm going to rub this part and we'll discuss the next one, friend. Wait for a moment. Now, the next question, listen carefully. In Lingam diagram, the slope of the curve of the formation of the metal oxide. Now, tell me what will happen. As we know, this one is metal, right, like this 2xm plus O2, it gives you 2mxO. The metals may be Zn, Fe, Mg, Al, maybe. This is the metal oxide. This is in a solid state. Now, listen carefully. Gas convert to the solid. That is, the randomness decreases. If randomness decreases, then what will happen? Sir, the entropy becomes negative. If there is a conversion from gas to solid, do you remember I have discussed in thermodynamics? If there is a conversion of solid into liquid or gas, then delta has become positive. Watch carefully. Here, metal oxide in solid form, that is conversion gas into solid, that is the randomness decreases. If randomness decreases, delta S becomes negative. Now, as we all know, listen carefully what I am telling. As we know, delta Z is equal to delta H minus T delta S. Clear? If I talk about this equation, that is delta S negative, with rise in temperature, what will happen? If temperature rises, then T delta S becomes more and more negative. Yes, sir, definitely. If I increase temperature, if I take delta S 2, negative, that is minus 2 into 300, minus 600, 400, minus 800. If temperature increases, then T delta S becomes more and more negative. If more negative part is subtracted from this part, then definitely the value of delta G decreases. That is, in terms, that is the value of delta G becomes less negative. That is, it moves towards the positive side. If it moves towards the positive side, then tell me, this is the graph between delta G and T. Yes, sir. If positive, then the slope will up like this. If negative, that is, graph will be like this. Here delta G become less negative, so we are moving towards upward side, because this zone negative, 0, positive, so on. So in this case, if delta G becomes less negative, then what will happen, friend? It's very simple. It is mostly positive. For question number 3, A is the correct option. Is it clear to you? Now I'm going to rub this part. We'll discuss the next one. Now, next question, question number 4. In amalgamation process, the gold combine with mercury to form amalgam. Amalgam, we know sodium amalgam NaHg, gold amalgam AuHg. That is a very simple method. Which method? Sir, it's very common. This is the theory based question. That is the distillation method. Clear? For this question, B is the correct option. That is, in amalgamation process, the gold combined with mercury to form amalgam is obtained by distillation. Clear, friend? No need to more clarification because it is completely theory based. Now let's move to the next question. What the sulfide O are common for the, this is the previous year JEE question. Sulfide O are common for, as I know, best one Ag2S, PbS, Cu2S. So these are very common. So in this case we can say sulfide O are very common for Ag, sulfide O are very common for Pb, sulfide ore are very common for copper. That is Ag, Cu and Pb. For question number 5, A is the correct option. Clear? Now I'm going to rub this part and we'll discuss the next one. Now it's your turn, solve. Here the given, consider the following: MgO, Al2O3, Cr2O3, Fe2, thermal stability. As we know, what is the order? Affinity for oxygen is follow the order Mg, Al, then chromium, then iron. This is the affinity, order of affinity towards oxygen. So if there is more affinity, then definitely the compound is more stable. If I talk about MgO, if I talk about Al2O3, if I talk about Cr2O3, and if I talk about Fe2O3. Clear to you? So for this is the correct choice. Now look at CaO, MgO, ZnO, Pb. Temperature at which reduction by carbon take place. Definitely this is the order, carbon reduction take place by carbon. This is the correct order. CaO, MgO, by using Lingam diagram, by using the complete Lingam diagram, we can easily say this is the correct. But here the third option, Cr2O3, Fe2O3 and MgO, temperature at which reduction by aluminium take place. Reduction take place in case of Fe and Cr2, thermite process we people know, but in case of MgO not possible. Al cannot reduce, cannot release oxygen from magnesium at around 15 to 1600 degrees Celsius. So this too is correct. That is known as thermite process we people know. Do you remember the reaction? That is Fe2O3 plus 2Al. It gives you Al2O3 and plus 2Fe. This process is known as thermite process. Yes sir, for this it is possible, but for MgO this is not possible. So we can easily observe for this question, yes sir, 1 and 2. First and second is the correct statement, but the third statement is not completely correct. Clear what I'm telling? First and second statement is correct, but third statement is not completely correct. So we can say which is the correct order? Sir, the correct order is 1 and 2. Where is 1 and 2? That is C is the correct option. Clear friend? Now I'm going to rub this part and we'll discuss the next question. Wait for a moment. Now wait, let's move to the next question. In the cyanide process for extraction of gold and silver from its ore, the cyanide solution, as we know, this process is known as leaching. Leaching is used for silver and gold, and they form a solution. That is, now the cyanide solution acts as a reducing agent to reduce the gold and silver compound present in the ore into the metallic. No, leaching agent to bring gold and silver into the solution. As we know, what will happen? They will form AgCN twice 2 minus. This is leaching agent. This will, in the cyanide process of gold, that is a cyanide solution, act as a leaching agent to bring gold and silver into solution as cyanide complex. This is a cyanide complex, and thus separate this metal from ore. Yes, this is the correct statement. This is known as leaching. So for this question, it is absolutely easy, absolutely true. That is B is the correct option. Am I right, friend? Yes, sir, you are absolutely right. For this question, B is the correct option. Now let's move to the next question. As I told you earlier, for this chapter, Lingam diagram and the extraction of Zn, Cu and alloys, these are the very important points. You have to focus on these. Basically, in Lingam diagram, clear to you, Lingam diagram completely based on thermodynamics. That is, we have to utilize the simple formula delta G is equal to delta H minus T delta H. Delta G is equal to standoff free energy, delta H is equal to enthalpy change, and delta S is equal to entropy change. And T is, we people know, that is temperature. Clear, friend? Now let's move to the next question. What I am telling, listen carefully. Which of the following conversion involves the calcination and carbon reduction? What is the calcination? As we people know, calcination process is generally used for the conversion of carbonate ore into oxide ore. This is simple thing. And roasting is done and used for the conversion of sulfide ore into oxide ore in presence of oxygen. Now, in this case, which one is carbonate ore? This one is, this one and this one. Clear? As we know, what will happen? ZnCO3 gives you ZnO plus CO2. Yes, sir. Similarly, CaCO3 gives you CaO plus CO2. Yes, sir. This is option. Now, this one is calcination. Now, carbon reduction. As we know, when we compare the reactivity, calcium is more reactive, and in this case, carbon reduction process is not a suitable method. In this process, what will happen? Sir, electrolytic process, electrolysis for reactive metal, we know the electrolysis process is suitable method because carbon cannot release oxygen easily from such reactive metal. But in case of Zn, these are less reactive than alkali and alkaline earth metal. So in this process, carbon can be used to release oxygen from ZnO and it forms Zn plus CO. So read the question again. Which of the following conversion involves the calcination? Both can form calcination, but then there comes carbon reduction. So this option completely match the question. So for this question, we people can say, wait for a moment. For this question, we people can say A is the correct option. Wait for a moment, friend. We can say this A is the correct option. Clear? Now I'm going to rub this part and we'll discuss the next one. Now, let's move to the question number 9. In extractive metallurgy of lead, the reduction of the roasted ore to the molten metal by heating with coke. This is the direct question. That is, in extractive metallurgy of lead, the reduction of the roasted ore to the molten metal by heating with coke is called smelting. Smelting is a process. Clear? This is a complete theory based question. For this question, that is, the process is smelting. So for question number 9, A is the correct option. Clear, friend? Now let's move to the next section. What I am telling, listen carefully. Now the next question is, tell me, if the impurity in a metal has a great affinity, impurity has a great affinity for oxygen, listen carefully, and is more easily oxidized than the metal, clear, then the purification of metal may be carried out. As I told you, if do you remember the example, if Ag contains Pb as impurity, if Ag contain Pb as impurity, then what will happen? The molten mass, or we can say the massy structure, is taken into a cupel. This is made of bone ash or cement, and at high temperature, when oxygen is passed over the molten mass, remember this, then what will happen? The impurities Pb combines with oxygen and form lead oxide, and the removal of Pb take place. We use cupel, and the process is known as cupellation process. What I'm telling? Cupellation. So if you want to remove the impurity in ore, then if the impurity has more affinity for oxygen, then cupellation method is the best method for the removal of such impurities. For example, if I take Pb, clear to you? So for question number 10, we all know A is the correct option. Clear to you, friend? Now wait for a moment. We will again review the sheet, review the all questions, and after that we'll move forward. Look at what I'm telling, listen carefully. Now tell me what will happen. Which of the following act as a depressant? As we know, depressant, that is which reduce the formation of froth, and with increase the formation of froth, which are known as activator, or you can say sometimes collector. Their activator, collector terms come, activator, collector, and depression. And we know NaCN when combined with ZnS, they form complexes, and due to the formation of complexes, they act as a depressant. So for question number 1, again I am repeating, D is the correct option. Clear to you? Now next question is, which is the better oxidizing agent? As I told you, by Lingham diagram, carbon, generally carbon, for ZnO, for CaO, for I have given a question in this session also related to this related to the involvement of carbon. So carbon is the best. Why? By using Lingham diagram, you can easily observe that carbon is the best oxidizing agent for ZnO. For question number 1, for question number 2, that is A is the correct option. Now let's move to the question number 3. In Lingham diagram, the slope of the curve of the formation of metal oxide, I have given a detailed solution. Then what will happen? In this case, delta G become less negative, that is slope will move above. That is, in this case, it is mostly positive. Clear? Now let's move to the next question. In amalgamation process, the gold combined with mercury to form amalgam. As we know, sodium amalgam, sometimes silver amalgam, gold amalgam, AuHG. It is a simple process, theoretical based question. That is, B is the correct option. For question number 4, B is the correct option. Now let's move to the question number 5. Sulfide ores are common for the metal. As we know, Ag, Cu and Pb. Ag2S, Cu2S, PbS. So question number 5, A is the correct option. Now for question number 6, as I told you, first option and second option is correct, but third option, this both two is correct, but this one is not correct. So the complete correct option here 1 and 2. So for this question, C is the correct option. Clear? Now let's move to the question number 7. In the cyanide process, we all know cyanide process. In this case, it is used for generally Ag and Au, and the process is known as leaching. That is leaching agent to bring gold and silver into the solution as cyanide complex, and thus separate these metals from O. So for question number 7, what is the option? So B is the correct option. Clear? Now let's move to the question number 8. Which of the following conversion involves the calcination and carbon reduction? As I told you, calcination is used for the conversion of carbonate ore into oxide ore, and this one is the correct option. But next is one more involvement, carbon reduction. Calcium CO, calcium is more reactive, so it is not possible to remove oxygen from calcium by using carbon. It's better to use electrolysis process, but in case of Jadan it is possible. So for question number 8, A is the correct option. Now for question number 9, in the extractive metallurgy of lead, the reduction of the roasted O to the molten metal by heating with coke is, that is simple explanation, this is known as smelting. What I'm telling, this is known as smelting. So for question number 9, A is the correct option. Now let's move to the next one. If the impurity in a metal has great affinity for oxygen and is more easily oxidized than the metal, then the purification of metal may be carried out. That is, the process is cupellation. So for question number 10, A is the correct option. I think now you can easily solve such kind of questions. If you have a strong command on theory, then such questions are very easy to solve. But again I am repeating, for this chapter, Lingam diagram is one of the most important topic. You have to focus on it. Clear? So friend, this is the last question of today's session. In my next session, we will meet again and we'll discuss few more questions related to the JEE Mains, JEE Advanced pattern. Thank you so much.